In this question, if possible, I'm going to show two different ways. However, for those of you that are taking Math 156 statistics with me in the spring of 2022, notice you can't see it, but there's a dash T. So perhaps the first method I'm going to show using the TI-84 may be required. We should get pretty similar answers either way. We're told the time required for an automotive center to complete an oil change is approximately normally distributed with a mean of 19 minutes and a standard deviation of 2.5 minutes. They guarantee customers that it'll take no longer than 20 minutes. If it does, then the customer will receive the service for half price. What percent of the customers receive the service for half price? Bringing up the TI-84. Going to second and distributions. Normalcdf, the second choice. We have 20 minutes as a lower cutoff. Anyone that it takes 20 minutes or longer, well, actually longer than 20 minutes, but or equal to's don't count when it comes to probabilities of continuous random variables. It's heading right to infinity. And there is no infinity symbol on the TI-84, so we have to put in a large positive number. 10 to the 99 is the largest that a lot of them can handle. You might have one that goes 10 to the 999, but the mean was 19, and sigma, the standard deviation, was 2.5. I'm going to back up what I've shown here by sketching. It should not take longer than 20 minutes. So mean of 19, standard deviation of 21.5. 20 minutes is somewhere in here. And so technically, because if they take longer than 20 minutes, technically we would have a dashed line at that boundary, a dashed line segment. But again, line segments are one-dimensional. They have no area. So the probability of that exact number, 20, would be 0. It contributes nothing if we say that x is greater than 20 or x greater than or equal to 20. It's going to be the same thing. So it's because of that shading that led me to the setup that I put in for Normalcdf. I'm expecting something a little bit bigger than 16. Let's see if I'm right. Once I can wake this back up. There we go. Pretty large indeed. So they want that converted to a percent. You're not really multiplying by 100. You're moving the decimal point 2 to the right. You're not changing the number. So you're multiplying by 100%. Then they want that to 2 places after we have it as a percent. So 34.46. Now, what would have been the other option? We could compute the z-score when z is, x is equal to 20. The mean, mu, was 19, and we've got 2.5 for the standard deviation sigma. So 1 over 2.5, you should find that to be 0.4. And whatever you get from the table will be to the left of that 0.4 So either use symmetry or a complement, but not both. Now, I don't see that option coming up here, which is why I thought they wanted the TI-84 to be used. So let me see if I can get the table to open up. Looking for a z-score of positive 0.4, which gives me the area to the left of it as 0.6554. So I would have to subtract from 1. I believe that's going to give us 0.3446, which is, when we convert that to a percent and round, it would already be rounded, that would be 34.46%, precisely what we got from the calculator. The other option, you don't want to mix these two, but the other option would have been to use the negative of that z-score, which would, by symmetry, mean that we're going to the left. Went the wrong way. Just a moment. Still not there. So negative 0.4. There's our 0.3446 by applying symmetry. Change the sign of the z-score, and it's going to change the direction. Okay, let's see what we have next here. Guaranteed time limit is what? So in part B, if the automotive center does not want to give the discount to more than 5%, one option is have that area, instead of being 0.3446, make that 0.05, which is what the 5% is equal to. Go to inverse normal and put in 0.05. Our mean was 19 and our standard deviation was 2.5. So I think they want to get a bigger z-score here, so a bigger x. Tell it you're going to the right. To the nearest integer, they'd want to go with 23 minutes so that they'd only have to pay that out to 5%. Interesting. Okay, let me see here. I want to get to more than 5%. I mistyped that 0.05, not 0.06. Round up to the nearest integer. So they're actually going to cut that down to, if we put in exactly that value, that should be exactly, or as close as we can get to 0.05 to the right of it as an area. So they want to shave a little more. There we go. Now, what would have been our other option if we used a table? We want this to only be 5% or 0.05. We hadn't done that work just a moment ago. Then I don't really know where 5% relates to this, but we want to be in the top 5% or 0.05. Either talk about that cutoff point being the same as the cutoff point for the bottom 0.95, or by symmetry, find a negative z-score in the table where the portion of the population corresponding to that would give you the bottom 5%. That is actually something I've seen show up quite a bit. So showing the table again. 0.05. If you look at this row of Z starting with -1.6, you have two scores that are the same distance away. And so if you had one of them where the proportion was closer to your given proportion, you'd pick the Z-score going with the closer proportion. In this case, because they're equidistant, you would pick the average, -1.645, by looking at the top of the column. So we're actually dealing with the Z-score going 3 places. So these were raw scores X, Z-score here. We want to talk about the top 5% though, so switch the sign, +1.645. If we look that up on the next page, you should see stuff close to 1.95, 1.64, and 1.65. So the cutoff score for the top 5% is the same as the cutoff score for the bottom 95%. Mu and sigma are the same. I'm using the positive Z-score because of wanting the top 5%. I don't really care what 1.645 times 2.5 is. I'm going to multiply both sides of this equation by 2.5 to get rid of the fraction without worrying what I get from the multiplication until the end. Because I still have to add 19 to get X alone. And let me make sure you can see that. So I'm going to type it in all at once, and that's going to give us the bottom for the number of minutes to get in the top 5%, and we'll round it up to the next minute like they did with the technology approach. So here comes the calculator. $19. Pick up 19 plus 1.645 times the 2.5 for the standard deviation, and 23.1125 when rounded up will give you the 24 minutes that we had just talked about. So let's see here. Oh, wrong one. There's our 24 minutes right there. And that looks like the end of that question. So on to another one.